Hi, so today we are going to talk about Serilog, Elasticsearch, Kibana on .NET Core. I'll introduce myself. My name is Maciej Szymczyk. I'm Big Data Engineer and Software Developer in National Cybersecurity Center, and I work there as a soldier. I am also a teacher at Military University of Technology. I have a blog, wiadrodanych.pl, on which I share my knowledge, and also I have a YouTube channel. And you can find me on some running or maybe something like triathlon events. So I'll start with my first web application written in .NET. That was MVC, and it was all screwed up from the beginning. All logic was in controllers, so somehow it was functional, but it was very problematic. And moreover, I had no I had no logging, I had no metrics. So even in the production, I didn't know what is happening in my application. So I had to ask customers what to do to reproduce bugs. And even later, when my experience was growing up, I figured out that many companies don't care much about logging and gathering metrics. And then we have complex apps, because that was my first app. That was a very simple CRUD application. So when you're a company, your applications are more complex. You have microservices, you have many instances of application, you have polyglot persistence, so you do not only have a single relational database, you can have some object database, document database, or other NoSQL solutions. Then you can have your application hidden behind a web server, for example, Apache or Nginx. Or if you're hosting your application on a Windows server, then this is IIS. And you can have many types of clients, not only web, but Android and iOS. Windows phones are gone, I think. And another thing is that you can host your application not only on host machine, but you can containerize. So you can use Docker, Docker Swarm, or Kubernetes. So that's also components that you should look aware, that you should take logs and take metrics and monitor them. Another thing are external dependencies. And here I mentioned DCM and APNS, so this is push notification services. But you can also have something maybe not so complex, but very crucial for your application, because your application can be slow, not because your application is slow, but someone else's application is slow, and you're waiting for the response. And you should be aware that you're not slow because of you, but you're slow because of someone else. So this is also good information to have. So what can we log? We can log usage, so clickstream, log requests, and this is used for audit or for simple statistics. In private sector, clients buy your application, so they use it for sure. But in internal projects and public sector, it's not so common. So sometimes people order application, but they don't have time to use it. So this is something that you should be aware. Next, there is a performance. So like I said, something can be slow, some queries can be slow, your connection to the database can fail, and you should be aware of that. Another thing are errors. So you should deliver yourself some stack trace, some classes, some methods that are using, and that provide some exceptions. And then there is debug, because sometimes finding a bug, it's not a simple. Finding a debug is not a simple task. So you can use your logs, you can use your whole system of logging to provide you with tools to debugging. So what can we log? So there are messages that we write ourselves. So here, hey, I'm here in the method 1, or now I'm method 2. Now I'm after some block of code. We can log requests. So body is something is sometimes body is too large to log, but sometimes it's small enough to log, especially if we are using log trace, log debug level. We can log query strings values and headers. So this depends on our situation. Next, we can log methods that we're using, parameters that we are passing, and these things are maybe more into the debug section, because if we provide too many logs, that will be not good for us, because there will be too many data and we will not have idea what to look at. So then we have user IDs or user IPs, so we can identify who has problem. Then client type and version, and this has connection with clients like I talked about earlier. So Android, iOS apps. So we can have version, maybe version 1 has problems with something and version 2 has not. So we should ping our clients to upgrade his version of application. Then we have services and machine names, and this can be useful in terms of microservices or maybe Docker components, because sometimes when you have Docker orchestrators like Docker Swarm or Kubernetes, that sometimes the problem can be with one host, not all cluster, but one host can be some problematic, and we should know that. And the last reason, the last thing that we can log is something like correlation ID or trace ID. And this is cool because when we have problem, for example, our colleague from the mobile application team sends us a message on Slack, hey, your API is not working. Then we can, okay, so provide me with some correlation ID, with some trace ID, so you can track the problem in our, for example, Elasticsearch or other solution. So he gives you trace ID that he was provided with, for example, request or header in a request, and then you can then you can fastly search that issue in your system. So how much should we log? Really, it depends. You should use log levels, so info, warning, error, and debug. You shouldn't provide so much information in info and leave it in debug, but you should write something in debug, because sometimes it can be too late. So if you have a problem and you didn't provide any logs, then you don't have any logs. So you have to write them again, build application, put them on production, and then look at logs. And what shouldn't be logged? This is also an important question. And security is very important, and not only security by means that someone's password on somebody's user, but you should be aware of someone's sensitive information. We have GDPR, or in Poland, as we say, RODO. So you should be aware that not every information can be stored, can be processed in your system. So you should be aware that maybe you should be aware. I will say with that. So where should I put my logs? So the easiest way is to use console. So you provide your, so you push your logs to the console, so you can look at it in debug or when you're developing an application. But it's not very scalable. When your application is on production, also on some remote server. Of course, you can SSH to the server and look in the console, but that wouldn't be good for the long term. So then there are log files, and that's also okay, because log files also can be looked from the remote server. You can grab them and look for some specific information, or you can use some log collectors to grab those logs events, those logs files, and put them into the something, someplace especially built for logs. And then the common choice is relational database, because we know the database, we use it every time. So many people think that they will use a relational database, and this is not so the best idea. I'll talk about it in a second. Then we have some specific solutions built specifically for logs, for Elasticsearch, Splunk, Loki, or many other tools. And when we want to have many logs from a long time ago, we can put them on HDFS, S3, or Azure Data Lake storage for the audit reasons or some analytics. So the problem with relational database is that at first the schema is fixed. So when there is a new field in your log, then you should alter your table in relational database, for example, MS SQL. Second reason is that building a graph and dashboards by ourselves is pain in the ass. So it's not very cool. You can use yes, you can use some tools like Power BI and other, or you can use your skills and build something in JavaScript, so dashboards. But this is very this takes so much time, and you have provide some people to do this. And there is a better way. When your only tool is a hammer, everything looks like a nail. So if you know MS SQL, then you would like to use MS SQL everywhere. But there are plenty of solutions, free or paid, which you can use to provide some logs and insights into your application. So there are cloud solutions like Datadog, and there are on-premise solutions, both paid and open source and free. So my choice is Elasticsearch, and you can choose what you like. So some people like Splunk, some people use Greylog, some people like Grafana Loki, which is, some say, more scalable than the other, but this is your choice. I prefer Elasticsearch. So Elasticsearch is a full-text search engine based on Apache Lucene. It is simply a document database from my perspective. We communicate with it with REST API. It's open source, it's very scalable, and there are multiple ways of injection of our records, logs, and etc. So we can use REST, we can use bits, which are part of Elastic Stack, like FileBit, MetricBit, Heartbit, and so on. And we can use Logstash, which is some kind of worker that grabs logs or other data, process them, transfer them, and push them into some kind of source. So it can be Elasticsearch, it can be some other database or file or queue, etc. So Elastic Stack is not only about getting and aggregating logs. It can be also used as a search engine, so you can use full-text search in Elasticsearch. Some people use Elasticsearch as a real-time business analytics, because in Kibana, which is a part of Elasticsearch, you can easily build some dashboards, graphs, and etc. And some people use use Elasticsearch as a CM, so it is security information and event management. And it is, to simplify this, you gather logs from all your endpoints, all your machines, virtual machines, into one place, so you can do a little bit of threat hunt, of monitoring. This is mainly based on cybersecurity practices. So let's compare Elasticsearch and relational database. In relational database like MS SQL, we have database. We can provide many databases in one database. And Elasticsearch is flat, so we have an index. So table is index in Elasticsearch, row is document, column is a field, and schema is mapping. So if you have experience with MongoDB, then Elasticsearch is something a little bit like that. Not exactly, but we use JSON, so it is very similar. So it is like MongoDB or like CouchDB, something like that. So let's talk about Elasticsearch architecture. We have Elasticsearch, which is the heart of our solution. We have Kibana, which is a UI for this solution. in Kibana, we can search logs, we can manage Elasticsearch, administer it, and we can provide some dashboards and graphs. Then we have Logstash, which provide logs to Elasticsearch. Logstash can get some logs, transfer it, and put into the Elasticsearch. It has also capability of queue, so it can take some logs and put them into the memory on our disk and wait a little bit if Elasticsearch is overloaded. And there are bits. Bits are light collectors written in Go. So you put that bits on your machine, for example, with database, with application, with web services, with servers, or any other tool. For example, you have RabbitMQ or Kafka. So also you can get logs and metrics using bits. And bits can provide logs directly to Elasticsearch, but also bits can provide logs to Logstash. Then Logstash can be used as a queue and some transfers or drop some logs based on conditions. And then Logstash can put these logs into the Elasticsearch. And also we can use HTTP. So because Elasticsearch is based on REST API, we can use just HTTP to push some logs and get some logs into the system. So let's talk about Kibana. Kibana, as I said, is a UI, graphical user interface to our Elasticsearch. And we can have the visualizations, dashboards. So regarding visualization, so we can build each of these graphs as a visualization. Then we put all these graphs into a dashboard. So we can deliver those dashboards to our developers, our administrators, or even if we use Elasticsearch for business clients, we can provide them to them. Then we can provide some analytics. And there are also modules related with uptime and infrastructure. So we can monitor our virtual machines, or we can provide us with data that this service is up, this service is down, or even that this service was down at 3 a.m. Yesterday. So we can have that history data to help us monitor our infrastructure, our solutions. And then, as I said, we have CM, so we can also look at things like someone was trying to access to this virtual machine, but SSH, or maybe it was brute forcing some machine. So this can be also useful because we don't want to lose data and leave it into the public. Okay, so as I said, Logstash is a worker that gets logs, or maybe there are some records from any sources and put them to any sources. So this can be files, some file servers, some database, and we can provide them to Elasticsearch, but not only, because we can throw them into the cloud, save them to file or to database, or some queue, so we can use it in multiple ways. And bits, there are many bits. File bit is for gathering logs, metric bit is for gathering metrics, packet bit is for NetFlow, but packet bit can be also used to monitor some solutions that have specific network protocol. For example, Apache Cassandra is using CQL, not SQL, but CQL. And using packet bit, we can monitor Cassandra, which is simply a column database. Then there is a winlog bit, audit bit, hard bit for uptime, and function bit used in the cloud. So what is the easy way to provide our logs to the Elasticsearch? We can use just HTTP. So in this presentation, I'm showing a Serilog solution, which it will be sending logs to the Elasticsearch cluster through HTTP. We can use Logstash. So when we store logs in a file, then Logstash can grab those files and send them into the Elasticsearch. And we can use bits because for example, we use some queue, for example, Apache Kafka or RabbitMQ, and some database like MS SQL and Postgres, and we can use bits to monitor those as well. So we can check how many queries were wrong, how many queries were good, and how long and how long it was to process them. And things can be a little bit complex because we have many solutions, and our Elasticsearch cluster is not capable of index so much data at a time. So we can use Logstash as a queue. If one Logstash is not enough, we can use multiple Logstashes. So this solution is scalable, and that's cool. And if we have a huge amount of logs, then you can provide some queue. So there are many queues, for example, Kafka, Redis, RabbitMQ, and many other solutions, really. So we can use them as a buffer, so we are not flooded with logs. And then we can use some consuments like Logstash, Apache Spark, or FluentD. You choose it, and save in Elasticsearch, and maybe in some Amazon S3 Azure Data Lake storage or HDFS. It depends on you, and depends on your case. If you want to have logs for audit reasons and store it very long time, then you can use those solutions. But Elasticsearch also provides some hot worm code architecture. And think about hot worm code architecture. Data has its temperature. So if we gather logs, at first logs are very hard, because we're looking at those logs, they're very valuable. And when time goes on, those logs, the value of those logs is not as it was before. So then it goes warm and then goes cold. There are many queries about regarding hot data, and less and less when the data is getting cold. So it's cool that Elasticsearch provided that solution for that, but it's cool that it's cool if we have that solution, or warm, hot, cold architecture in our log solution. So we can put hot data on SSDs on very fast servers, and then when the data is getting colder, we can move them to some cheaper and slower devices, so slower hardware. For example, not SSDs or NVMe SSDs, but on spinning hard drives. And maybe for some period of time, the data is necessary to hold. And after, for example, 3 months, we can surely delete logs and nothing will be wrong about it. So as I said, Elastic Stack is scalable, so we can scale not only Logstash, but also Elasticsearch. And as you see here, we have many roles of Elasticsearch nodes. There are 3 master nodes in a production server, at least 3 master nodes, which handle metadata. We have ingest nodes, and we have data nodes. And really, data nodes will be the most powerful nodes, the most beefy, with the good amount of CPU and good amount of RAM, with fast hard drives. And we can scale this to enormous sizes. So the minimal recommended cluster for Elasticsearch is at least 3 nodes, 3 master nodes, 2 data nodes, but you can for sure put another data node on this host, and coordinator nodes. And the coordination node is a node that do not store data and do not store metadata, but aggregates queries. So you can provide some lightweight virtual machine that will be part of the cluster, but will not hold data, but will coordinate queries. So this node can get your query from the client, then spread the query to the rest of the cluster, get information from those nodes, aggregate them, and return the message to the client. So talking about scalability in Elasticsearch and indexes, as you may remember, index is like a table in database, relational database. So the reason why we can scale this solution is that indexes are made of shards. So shard is a part of Elasticsearch index. It's like a table. Let's assume that you have table with 9 rows. So when you split this table into 3 parts, you have 3 parts which contains 3 rows. And those 3 parts you can move on you can move to different Elasticsearch clusters, not clusters but nodes, and then you can distribute this. And when you query for something, when you look for some information in your log, then the query is sent to all nodes that have this index or the shard of this index, and that's why Elasticsearch is so fast. So we can scale out the solution. And of course, we have also replicas, because if one node dies, then we should have some spare replica. So we should have some spare shard that can help not abandon our data. And this is something like this. So we have posts index, and we have 4 nodes. And this index contains of 3 shards and 1 replica. So each shard has its own replica. And imagine that node 2 collapsing. So we lose shard number 2 and replica number 3. And this is what will happen. So replica number 2 will be now primary shard, because we have only 1 shard and 0 replicas of shard number 2. Replica 2 will be cloned from the shard number 2 and put in the clone node number 4, and the same with replica number 3. So shard number 3 will be allocated and put as a replica into node 1. So we lost 1 node, and everything is all right. We can deal with it. What about pricing? So Elasticsearch has an open source edition and some not open source and paid. But really, all we want is contained in basic license, which is free. In Gold license, we have reporting, we have Watcher, which is just a alerting solution, which can be replaced with some open source project like ElastAlert or PROIDEA. And then there is Platinum, which gives us machine learning and advanced Elastic Stack CircuitD features. And machine learning is a simple machine learning here. It's something like anomaly detection. And Enterprise, which contains of Elastic Endgame solution, which is basically anti-malware, threat hunting, and in general cybersecurity stuff. So we can do a lot of things in just a basic free edition. And to compare this with Splunk, Elasticsearch is paid per node, and Splunk is paid per ingestion. So if you ingest in Splunk, for example, 20 gigs of data every day, then you have to pay more and more. The best way to try Elasticsearch is to use Docker. So you can run it on your machine. And then we have demo, and I will show you something. So I'm using Docker Compose, but not on this machine, but on other machine. So this machine, it's not so overloaded. Docker looks like this. So there is APM server, which I'll talk about later, Elasticsearch node, and Kibana node. This file will be in repository, so you can check that later. Okay. I have Elasticsearch on other computers, so it's that address. Here I'm in Kibana. I'm using developer tools to provide you with some information. And as I said, we talk with Elasticsearch with REST API. So in Kibana, we have some like developer tools that are something like talking with Elasticsearch with HTTP requests. So we have delete, post, get, post, and etc. So what I'm doing now, I delete this some logs index, and I add some logs to this again. So when I add some logs or some document like here, we have message, date. You see that this is just a JSON. I can add something here, something, and this is 100. And okay, it was added to the database. So the schema is dynamic. So this has some pros and cons, of course. You can see like how our index looks like. So we see that this index is default. So number of shards is 1, number of replicas is also 1. And we have our mapping. As you see, something is of type long. When I add, for example, something else, a, which is a string, then you see that this, oh, it's here, that the a was added and our mapping was updated. So now I'm going to add some other logs. And as you see here, I have added a log that will simulate that error. So we have error, message, and etc. So as I added this, I can use this ID, which is automatically generated, and get that information, that exactly that document that I was adding. So this is the document. But we can also search. But look at this query. I'm searching for some document in this index that contains error, but I'm not specifying any column. In the relational database, you had to use where column 1 equals something, when column 2 like something. Here I can just write that, and it will search that for me. Okay, so we have added some logs. Let's go to the Discover tab in Kibana. I have already added some index pattern with these logs. As you see here, we have we can filter our logs by date. So I have added those logs with some odd time. So I just click this. This will show us logs from today. And you see here, we can just look at these logs and get some info about what is going on in our application. We can also type something here, and like I did in developer console, we see that there is something here. Okay, so another thing is to show you some visualization. I have added some records of the cars. So there's price, color, make, and when it was sold. Now I'm going to visualize, create new visualization. I'm going to use lens because it's cool to see and cool to use, but it is in beta. So now I'm going to use price on y-axis and maybe make on x-axis, and then provide some color to break down. So as you can see, in a few seconds, I've created a graph. So we can see that BMW is red, Ford is blue and green, and Honda is red, and average price of those is like you see. We can also click some other graphs, so we can provide some pie chart. We can build some graph like this, or like this, or like this, or maybe some overall metric graph. And we can later save it and provide some dashboard with it. But let's move on to the next slide. As you can see, Elasticsearch with Kibana is very powerful. It can provide many things in just a few clicks. So why we should use Serilog and not standard logging in .NET Core? So Serilog provides us with structured logging. It's easy to use, and it has multiple things. So we can not only save logs to a console, but you can save logs to a file, so some other solutions like Elasticsearch, Splunk, some databases, queues, and etc., or just throw those logs on HTTP, on UDP, or TCP. It doesn't matter. You can use all of them at once. And it is integrated with .NET Core. So it's time for another demo. This can close. So I'm in Visual Studio, and I have some simple web application. And here we can see that I'm creating a Serilog logger. Of course, we can provide this in dependency injection, but it's not the case. I just want to show you how logs look like in iLogger, a standard solution iLogger, and in logger provided by Serilog. So here I'm configuring my logger, which is Serilog logger, and write it to console. Later, I'll show you how those look in file system, in log files. So here we'll be seeing standard logging. So, hey, I'm user X, you are in the index, here is some for, and catching exception, and this is the same, but in Serilog. So now I'm starting application. And as you can see, these are standard logging, and these are Serilog logging. So we can see that there are more colors, and really it's very similar. So what we gain with that? So let's close it. And let's uncheck. We have a little time, so we can just do this. We use write to file with JSON formatter, and it will be rolling interval of day. So I will start it again. Okay, spinning up. Okay, so now let's look at how this file will look. This is this file. So we see that here we have some additional information, unlike in console. So we have timestamp, log level, message template. That property we are attaching in a for loop. And in case of exception, we have error, message template, exception, the whole stack trace with line. So this is useful. We can use it, we can store it and watch what was wrong in our application. But let's back to another slide. The problem with simple using Serilog logger is that we have to maintain it, we have to wrap it around our solution. So it is easier to use built-in ASP.NET Core Serilog module. and not doing that by ourselves. So implementing a wrapper, configure it, configures others to use it, replacing iLogger usages, because as I will see you to you in a moment. I have some other part of this application which already uses iLogger solution, and I don't want to even replace it with some proprietary, some specific library solution. And we also have to remember that we should have some common schema around our solution. So, for example, in one application we have username, and in another application we have user.name. So this will be difficult to search. Okay, so I will show you how it can be done with using Serilog as a built-in solution is ASP.NET Core, and using Elasticsearch as a backend for our logs. So at first, I will go to Program. I will comment these lines and uncomment these lines. So here we have configuration file, and we build our logger, which is built from configuration and add some config. And we can enrich this logger with some property like service name and the name of this application. Then we can just inject it into our solution. And here also I have to comment and out comment. You can find the solution in GitHub of Serilog ASP.NET Core. So another thing is to modify app settings. So we can comment the standard logging and uncomment Serilog logging. So we can see minimum level of logs here and things. So we will write to console and we will write to Elasticsearch. Of course, we have to download NuGet packages, but it's easy and it's cool that we can configure it from the app settings. So once you download those NuGet files, then you can switch and modify configuration from the application settings, and you don't have to rebuild the whole solution. And the last thing, I think, is a startup. Previously, in the previous Serilog versions, we had to write our own middleware to provide some loggings and gather those logs regarding a request from ASP.NET Core to Elasticsearch or other solution. Now we can use internal built-in library middleware, use Serilog request logging. So I think this is it. So we can play this application. I see we have not much time left. So now I have my calculator. I can calculate things. I can add. As we can see here, the whole thing now is Serilog. So from the start, we have Serilog format in console. So there are many colors here, which is cool. We see that every request now is logged in our application, and we can see that request finished in hey. Mogę mówić chwilkę dłużej, tak? Dobra. Okay, so let's continue. But the thing is that I didn't handle the divide by 0, so we can break our application. And something will explode. Oh, yes, it is. So there is a problem. So client is shouting at us that application is not working, but he gave us this request ID. So we can just copy it and move to our Elasticsearch. So let's go to the Kibana Discovery tab. Let's change index to our calculator. And as we see here, we have some logs with error. But now I'm going to filter span ID, which is default field in if in ASP.NET Core, and I will show you this value. Update. So as you can see, or not. Oh, okay. Save. Oh yeah. So let's add, because we have time and source, we can add another column which will be message, and we can see that all what was going on in our application. So we can see that there was some error. We were executing action, root match. So we want to filter only log level of error. Let's add this to our filter. So now we can see what was going on. And oh yeah, we can see our exception, system divide by 0 exception. So now we know what was wrong in our application, and we can easily fix it. Another thing that I wanted to show you is a system that is used by ASP.NET Core. So there should be another application and remote calculator client, but we have not time for this. So I'll just skip that and show you that in a presentation. So the middleware I was talking about earlier, we had to just write this out by ourselves. Now we can use Ready Steady from the library, but we can still provide another middleware and enrich our log with some data. Maybe you want to log of some headers from your request, etc. And the thing that I wanted to show you is trace ID. So if one service is communicating with another service written in ASP.NET Core, then they share the same trace ID. So I was looking at the moment ago, I was looking for some logs from depends by span ID, but as span ID, you can also have some trace ID. And trace ID is a common field across many services. So if service 1 is communicating to service B, then service B is communicating to service C, then you can look at all this chain and look for logs from all those controllers or those services that are related to this task. And this is what I wanted to show you here. So another solution provided by Elastic Stack is Application Performance Monitor. It's as simple as downloading a NuGet package and enable it in Startup CS, and it can simply automatically provide some metrics to APM server, which we can then look in Elasticsearch in this form. So you can test it on your own later. So here are main takeaways regarding Elasticsearch. Do not exceed 64 gigs of RAM per node. because Elasticsearch is written in Java, and JVM have some problems if the JVM heap is is bigger than 32 gigs. So it is recommended not to exceed 32 gigs and put, for God's sake, 31 gigs. You should provide some SSDs for hot storage and just static hard drives. Magnetic hard drives are slow. You should avoid NAS or SAN. So you should put those disks in the servers, not to use some network attached storage. Use Elasticsearch common schema or some other common schema, because, as I said, if you have logs, for example, user.name and username in another service, then everything is a little messed up and this solution should provide you some easy way and not the hard way to look for logs. And to monitor and administer logs, you should use ILM, which is Index Lifecycle Management, and it can provide you that thing that was talking about in hot form code architecture slide. So you define rules that, okay, after a month, our logs are moved to warm storage, after another month, they're moved to cold storage, and after 3 months, they are deleted from our database. So you don't have to look and do this manually. So thanks for all. If you are interested in Elastic Stack course, I'm building this right now. It's not so easy when you have a 1-year-old daughter, but I keep on doing something. And in the first link, you have a repository with Visual Studio project that I was using here. So thank you for all, and we can go back to the studio.